Rashmi. My matrix number is 280376. So today we are going to do our question 1 from chapter 4. So let's start doing this.
This is our question 1, and these are the steps we are going to do. So these are the things that have been asked in the question, and our step 1 will be find the x-intercept, y-intercept. So the x-intercept for the function given. Okay, so if you want to find the x-intercept, our y must be 0, means our fx must be 0, must be equals to 0. So we can see that here we have x power 5. So x power 5 is a highest power, so we can factorize our function like this: x power 3 and x square minus 5 equals to 0. So when x power 3 equals to 0, our x will be 0, and then x square minus 5 equals to 0, we will get x equals to plus minus square root 5. Okay, so we will get 3 values for x, that is x equals to 0, x equals to negative square root 5, and x equals to positive square root 5. Okay, and in interval form we can write like this: 0 when x equals to 0, fx equals to 0. When x equals to negative square root 5, fx equals to 0. When x equals to square root 5, fx is 0. And then we have to find our y-intercept. If you want to find the y-intercept, our x must be equals to 0. So we have to substitute our x equals to 0 in our function given: 0 power 5 minus 5, substitute 0 and power 3. So we will get 0. So when x equals to 0, our fx equals to 0. So in interval form we will write like this. So we already finished the step 1, x-intercept and y-intercept. Now we can move to our step 2, which is find the critical point. So fx, with the function given, we have to find the critical point, but we have to use the first derivative. So we will get this one after we derivative the function, and after we differentiate this function, and we have to use f prime x equals to 0. So we will get like this equation, and we have to factorize this equation to get the x values, to get the critical points, okay, to get the x values. So this is fx power 4. This power 4 is the highest power, so it will be difficult for us to factorize. So we did like this: fx square in bracket x square minus 3 equals to 0. So fx square equals to 0, we will get x equals to 0, and x square minus 3 equals to 0, we will get x equals to square root positive negative 3. Okay, and we will get 3 values, which is x equals to 0, x equals to square root 3, and x equals to negative square root 3. So after that we have to substitute these x values into the function given. So when x equals to 0, our fx is also 0, we have to substitute. Okay, and then when x equals to positive square root 3, this is just a decimal point of square root 3, I just write here. Okay, so but when substitute, we have to substitute the square root 3, because that one will give the most accurate answer for us. Okay, so f square root 3 equals to, then just just substitute this square root 3 into this function, and we will get negative 10.3923. So when x equals to positive square root 3, our answer for fx will be negative 10.3923. Okay, when x equals to negative square root 3, this is the point form of negative square root 3. Okay, we have to substitute. So f negative square root 3, we will get, substitute here, and we will get positive, okay, 10.3923. okay, so we will get the critical points, which is when x equals to 0, fx equals to 0. When x equals to 1.7321, fx is negative 10.3923. when x is negative 1.7321, our fx will be 10.3923. okay, so we can move to the next one, which is we have to test the values we got. Okay, we have to test. We just now we got this one, right? Now we have to test this one. Okay, for that I have did a timeline which is negative infinity to negative 1.7321, 0, 1.7321 positive, and positive infinity. Okay, so we have to do this table for get this conclusion whether our graph is increasing or decreasing. Okay, so just choose this one. Okay, interval from negative infinity to negative 1.72. okay, and from negative 1.7321 to 0. okay, and 0 to 1.7321. okay, and then 1.7321 to positive infinity. In this column, this x column, so we just can pick up a random number from our interval. Just pick any random number from here. Okay, so I pick negative 2, and here I pick negative 1, and here I pick 1, and here I pick 2. okay, so after that, okay, just notice here, pick randomly from the timeline, pick randomly. okay, but you have to follow this interval. okay, and then f prime s. okay, this column, in this column we must substitute our x values in this function. okay, this is our first derivative function that we have did before. Remember this one we have did before. okay, we have to substitute in that function so that we will get these values. okay, from these values we can conclude that it is increasing, the function is increasing or decreasing or what. okay, so here we can say that f prime x, if more than 0, it's increasing. If f prime x less than 0, it's decreasing. okay, decreasing. okay, this one, if less than 0, decreasing, more than 0, increasing. okay, so now our f prime x is 20 is positive and more than 0, so it's increasing. This function is increasing. Negative 10 less than 0, so this is decreasing. This is negative 10 decreasing, 20 increasing. So let's move to the step 3, which is in step 3 we have to find the relative extrema. okay, so fx equals to, with the function given, okay, and then we also find the critical point, right, with this first derivative function. So if they say inflection point, we have to remember that we have to use the second derivative. okay, second derivative means f x, okay, f prime x equals to 20x power 3 minus 30x. so I have derivative this function, okay, second derivative. okay, then this one we must be equals to 0. okay, f prime x equals to 0, and this one is second derivative. okay, just remember, if inflection point we have to use the second derivative. So 20x power 3 minus 30 equals to 0. so we have to factorize like normal. okay, and then 10x equals to 0, x equals to 0. so 2x square minus 3 equals to 0. Our x will be positive negative square root 3 over 2. okay, so our x equals to 0, and we got three values. okay, x equals to square root 3 over 2 and x equals to negative square root 3 over 2. so this is in the point form. okay, so Then we have to substitute, and after finding these x values we have to substitute in our function, and we will get if we substitute x equals to 0, we will get our fx equals to 0. And if we substitute positive square root 3 over 2, we will get our fx value negative 6.4299. And if we substitute negative square root 3 over 2 into the function, we will get fx equals to 6.4299. So we will get this one. This one is okay. So when x equals to 0, fx equals to 0. When x equals to 1.2247, our fx value is negative 6.4299. And when x equals to negative 1.2247, our fx will be 6.4299. So then we can move into our step 4. But before we move to step 4, okay, we have to test our value, okay, which is I did this timeline again. First, second derivative, okay. So second derivative, and just do like just now, negative infinity to negative 1.2247, and negative 1.2247 to 0, 0 to 1.2247, 1.2247 to positive infinity. So this one is our interval we can take from this timeline, and this one is x values. Just pick up randomly from your interval, okay, from this timeline, but remember you must follow this interval. And this one we have to substitute in our second derivative function, which is okay, second derivative function, which is this one. So we have to substitute the x values into this function. So if we substitute, we will get negative 100, 10, negative 10, 100. Okay, so when is less than 0, it is concave down, means we will have this kind of graph, means sad face, okay. So when positive value more than 0, and it will concave up, okay, and negative 10 less than 0 will be concave down again, okay. Negative means concave down, positive means concave up, okay. So 100 more than 0, we will get concave up, okay. This will be our conclusion, okay. And then we can move to the step 4, okay, which is sketch the graph, okay. So I just write all the points I got from step 1 to step 3, and so make it easier when I draw the graph, okay. So these are the points I get in step 1, x-intercept, y-intercept. This one step 2, critical points, I get this one. And in step 3, I get inflection points, all this, okay. So now this is my graph, okay. I have did my graph. So first of all, we must have the y-axis, x-axis, and then we have to plot our graph based on the points, okay. So okay, I just plot, okay, just plot from this values, okay. 0, 0, okay, 0, 0, negative square root 5, 0. So this is the negative square root 5, 0, then positive square root 5, 0, positive square root 5 and 0, okay. And this one 0, 0, again 0, 0, then positive 1.7321, okay, 1.7321 somewhere here, and negative 10.3923. so here is the point, and negative 1.7321 somewhere here, and 10 positive 10 point. Okay, here is the plot. Okay, and then the inflection point, okay, 0.00, and then 1.2247. where is the 1.22? okay, 1 point somewhere here. Okay, 1.2247, and negative 6.4299. so here is the point. Okay, here is the point I have plot, and negative 1.2247 somewhere here, and positive 6.4299. so this is my plot. Okay, I have done plotting my graph. So then I've just sketched my, because they asked to sketch the graph, right? So I've just sketched my graph. Okay, so this is concave. Okay, we have to use the concave one. Okay, this is concave down, and this one concave up. Okay, so we get our this graph, and then we can, from this graph we can see that we can find that which is our local minima and local maxima. So this peak is the local maxima, and this one is the local minima of this function. Okay, and we have done this. Okay, we already finished our question 1. So I hope all of you understand. Thank you.